Fifth question has, okay, sine of ax plus b, cos of ax plus b. How do we handle this one? How do we handle this one? Let's take a look at this question. So we have sine of something, cos of something. Let us write integral I as sine of ax plus b times cos of ax plus b dx. The first thing that we observe is this ax plus b is looking pretty complicated, is it not? Yes, it's looking pretty complicated. But other than that, this sine and cos product is also complicated, right? So can we apply some concepts of trigonometry to merge these expressions? Merge these expressions, what do you mean by merge? Okay, I want to use this identity that 2 sine theta cos theta is equal to sine 2 theta. Do you recall this? Yes. 2 sine theta cos theta is sine 2 theta. You remember sine 2 theta is 2 sine theta cos theta. Therefore, this 2 here, sine theta cos theta will be half of sine 2 theta. Yes. Using this one over here. This is what I want to use. This integral will convert to what? Sine theta cos theta will be half of integral sine 2 times ax plus b. Dx. This is what you have. Right. And this is a simple sine. This looks like sine 2 theta, right? How do we handle this? So for handling this, there's one relation, right? There's one relation. We can use that relation, but without using that relation. What is that relation? We'll be talking about that. If instead of sine x, we have a sine of linear polynomial in x, then what do? We'll be talking about that. That is something that I've dealt with in exercise 1 as well, along with exercise 1. But I'll deal with that again over here since it is a concept of substitution that's required over here. But in this particular question, how do we solve it directly? So this huge complicated expression is creating problem. Let 2 times ax plus b is equal to new variable t. If you write it as this, then this tells me, okay, 2 times a times dx is what remains. 2 times a dx, 2b the derivative is 0, this is equal to dt. Okay. So therefore I will be equal to what? Therefore I will be equal to integral, there is a half outside, sine of this whole expression which is sine of t dt. Yes, this is what you will get. Okay, half remains as it is, integral of sine t is minus cos t dt. Now this becomes minus 1 by 2 cos of that huge expression. Okay, there's just one issue. What's that issue? We missed out on one particular thing. Let's not miss out on things. Okay, sine of t is okay. Dx is not directly dt. Dx is dt upon 2a. Remember that. This is dt upon 2a. Okay, so dt upon, let's get rid of this, and at this stage what do I have? I'll have a 1 by 2a. Okay, the integral of sine t is minus cos t, 1 upon 2 is already there, 1 upon 2a is already there, and you'll have a constant of integration, right? Let's not miss out on things. This is what you'll have, and this becomes minus 1 upon 4a cos t plus constant of integration, right? Missed out on the constant of integration. Minus 1 upon 4a is okay, cos of t is equal to what? That 2 times ax plus b. This is what it is equal to, plus constant of integration. That is the required answer for this particular question. Okay. And what is that important result that I wanted to share with you? The important result is this, that if integral of fx dx is equal to capital Fx plus constant of integration, then integral of f of linear expression ax plus b this dx. If you have a linear polynomial, instead of x, if you have a linear polynomial, this becomes capital F ax plus b upon a plus constant of integration. Similar expression, just that in the right hand side you have to divide by that a. That expression has to be divided by a. This is only true if you have a linear polynomial here. If you have a linear polynomial here. And for deriving all of this, what have we done? We can simply say, for deriving all of this, you can simply use substitution, right? Ax plus b. For solving this, what you can simply do is ax plus b can be replaced by t. Similar manner, in a similar manner that we have done over here. If ax plus b is equal to t, then a times dx will be dt, and f of t dt upon a is what I'll get. Integral of f of t will be capital F of t, and there will be a in the denominator. Yes, t can be replaced by ax plus b, and this is what you get, right? But this is one thing that you need to remember from now onwards, right? This will be used over and over again in multiple types of questions, and we need to remember this, right? We'll memorize this, and this is using the idea of substitution that we have derived this. Okay, and this could also be done with the help of simple inspection as well, but using some, let us say, substitution, this becomes very simple. The solution of this particular question is this. You could have also begun in another way, that you could have said, okay, sine of something dx, I know how to integrate that. If this is a linear expression, this will be half is okay. Sine of something will be minus of cos that something divided by the coefficient of x, which is 2a, plus constant of integration. And this, can you observe that this and this are the exact same answers? Minus 1 by 2 into 2a is minus 1 by 4a, and you have cos of that huge expression plus constant of integration. Exact same. So after this, you could have moved in this direction. Instead of going this longer approach, you could have moved directly over here, provided this is a linear expression. This is a linear polynomial in terms of x, right? That's what you have. So with the help of this result, many such questions can be solved easily, right? These long steps of substitution can be skipped, right? Okay. So that's the fifth question for us. Yes, that's a complete solution and one extra result based on that. I'll get aside so that you can take a look at this. That's a complete solution of this fifth question.